pressure in a fluid number 1. So there are 3 important sentences to remember here. First of all, the most important one is that pressure increases with depth. That's illustrated by the diagram on the left. We have a dam in brown, and the width of the dam is greater at its base than it is at the top. And the reason for that is as you go further and further below the surface of the liquid, the pressure due to the water increases, so the dam's width has to be larger to compensate for that. The second sentence is an explanation of what pressure is. So pressure is related to the number of particles hitting the surface per second. How that relates to the dam is that there are more particles hitting the surface of the dam per second down at the bottom than there are at the top. And that has to do with a number of factors, including the density of the water down towards the bottom. The third sentence, I'm not putting this down in text, is that pressure always acts perpendicular to the surface. So if we look at the dam at the top left-hand corner, we have 2 sections to the dam. One of them, we can see the arrows going horizontally, and that's the pressure experienced by the walls of the dam caused by the water particles hitting off it. And then on the bottom, there's a diagonal section of the dam. Again, the base is larger, and what they've done there is because the base is at an angle, the pressure acts at a right angle to that surface, so it acts diagonally down to the right, and as a result, some of the pressure due to the water acts to the right, but more of it acts downwards, and as a result, some of that pressure is transmitted to the ground or the solid stone that the dam is built on. Okay, if we look at these, so I said pressure increases with depth. If we look at the top video, so we have somebody up at the top of the Himalayas and somebody at the bottom of the Himalayas, let's say, or a mountain, just a general mountain. So at the top of the mountain, the pressure is less, and that's because that person is below a particular sea of atmosphere, so a certain amount of atmosphere, but at the bottom, that person is below a larger amount of atmosphere or a larger sea of atmosphere. So the person at the bottom is at a greater depth below the atmosphere, so they experience a greater pressure. Now, there are consequences of that. For example, when someone climbs up a mountain, they feel lightheaded, they have issues breathing, and so on and so forth. And again, that partially that has to do with the density of the fluid, which is air in this case, decreasing as you get higher and higher. Now, the bottom image then, we have water in a can, 3 holes in the can. I'll show you this in video form if you haven't seen it already. And if you seal those holes initially, fill the can with water and then open the holes, what will end up happening is that the bottom hole will produce water with the strongest jet. And that's because the pressure at the bottom is greater than at the other 2 heights. So if there's a greater pressure at the bottom, that means the water is pushed out of that hole with a stronger jet and it will travel further. The hole above it and above that then are at lower depths, and as a result experience less pressure, so the jets of water come out at less pressure as well. Okay, so that gives us a formula that relates the pressure in a fluid to the depth. Now, what are each of those quantities? Well, rho is the density, g is acceleration due to gravity, and h is the depth. And you can see there's a relationship between pressure and depth. They're directly proportional. Also, pressure is proportional to density. So the bigger the density, the bigger the pressure. And what that means is if the density is greater, there are more particles contained within the container, we'll say, and as a result, more particles mean there's more collisions off the surface. More collisions, greater pressure. And I'll show you that in a moment.